welcome. It's weird that the screen's not behind me, but welcome. I am Jessica Lord. I'm an engineer at GitHub. I work on the Atom team, which is the team that houses Electron. And we're actually going to split this session into two talks, and I'm going to first give an introduction to Electron, what it is, how we came to build it, and how you interact with it. And then we're going to do another talk. There's a huge spoiler alert in front of me, and I think that you'll be really excited. It'll be a talk from Jibo about how they're using Electron, and maybe you can guess how. After that will be the Electron talk from Jibo. All right, so what is the story of Electron? The story of Electron will always begin with the story of Atom. How many people have heard of Atom? Yes! Atom is GitHub's open source text editor, which you all seem to know. That's great. And the dream with Atom was always to build a desktop application with web technology, with HTML and CSS and JavaScript. And so when the team set out to do that, they started looking for tools to use to be able to do that. They tried the Chrome Embedded Framework first. They tried NWJS, which used to be called Node WebKit. But nothing was quite right, and so it became clear that they were going to need to build something specifically for this Atom vision, and that's really how Electron got started. The Atom team hired Chang, who was the lead developer on Electron, who was a heavy committer to Node WebKit previously, and he shared the vision with the Atom team of what Electron could be. So in the beginning, January 2013 is when Electron began. It was open sourced in May of 2014 with all of Atom. And then in April of this year, it was named Electron because, like many famous people, it was born with a different name. It was born as Atom Shell because it was built for Atom. But it became clear as more and more people were using Electron that it really needed to have its own name and not always be tied to the text editor. So, what is it? It is a framework for building cross-platform desktop applications with web technology. That's the one-line summary of Electron. But what does that really mean? That means that you're building a desktop application with HTML and JavaScript and CSS. You're not using native. You're not writing Objective-C. You're not writing C#. You've got one code base and not three. You've got one team and not three. And this is a really cool thing. And you can actually write native code if you want to. You can include native modules in your Electron app and use them, but you don't have to. You can write it all in CSS and HTML. So how does it do this? Electron combines Chromium's. All right, wait, let me back up first. Chromium is the open source version of Chrome the browser. Do you all know about Chrome browser? Yes. OK, cool. It's the open source version of that. And Electron takes the Chrome content library that is just in charge of rendering web pages. So Electron takes that and combines it with Node into a single runtime. And Google built an engine, a JavaScript engine called V8 for Chrome, and Node was then built using that same engine. So it makes a lot of sense for them to get to share this space. And so with Electron, with this combination of Chrome and Node, you're always going to get the latest and greatest features that come out in Chrome. So everything that Google is developing and putting into Chrome, you're going to get built into Electron too. And you're only going to ever have to design for one browser. So if you're used to designing web apps and websites and using all the prefixes and worrying and checking how it looks in every single browser, you're just designing for one single browser when you're building an Electron app. And because Node is baked in, you have access to the file system from everywhere inside of your Electron app. And because you have Node, you have access to the 190,000 plus modules that have already been written on NPM. So you can use them everywhere in your Electron app as well. And so Electron lets you package your app for Mac and Windows and Linux. You also get access to all the native system UI elements. So opening file dialogues and getting alert messages and styling menus and the system tray. All of that stuff you get for all the platforms with Electron 2. It also ships with Squirrel for automatic updates on Mac and Windows. This is something that GitHub built for its desktop apps. And then it has no configuration Windows installers for the Windows applications that you're building. And that's really the basics of what Electron is, how it combines Node and Chrome into a single place so that you can build apps with HTML and JavaScript. And now I'm going to talk a bit about using Electron. So the main things that you need to understand when you're using Electron is there are two processes. There is a main process and a render process. And so this main process, this is the life cycle of your application. It controls when you're starting your app, when you're ending your app. And it comes with some modules that are built into Electron that are built specifically for the main process. There's a dialog module that lets you interact with those open file dialogues and system UI elements. The menu lets you create your system level menus, and you have full access to all the Node APIs. There's a module called IPC, which is inter-process communication, and I'll talk about that in a minute. But then there's also another module called browser window. There are still some more modules, but we're going to focus on browser window now because the browser window module for the main process lets you create the second process. The second process is the renderer process, and that's your web page. And the renderer process, it also has modules that are built for it in Electron. You also get access to all of the Node API. You also have the DOM because it's a web page, so you have Node and the DOM living in one process. And then you can see it also has an IPC module, and it's these IPC modules that the main process and the render process use to talk to each other. So if your web page has a button that you want to be an open a new file button, what you do is you use IPC to send a message back to the main process because the main process handles those system level things. And you ask the main process to open a file dialog, it does, and then it will return the user's response back to you in your render process. And you don't have to just have one render process, you can have many. You can spin up as many as you need, and you don't even have to make them all viewable web pages. You can actually spin up a render process that's just executing JavaScript for you so that you can sort of farm out tasks that would otherwise slow down your web page, and they can run in the background. Another way to sort of think about the main process and render process context is if you think about Chrome. If you have Chrome open and all of your tabs are closed, you're still going to see the Chrome at the top and the file edit view. That's like Electron's main process, right? That's the place where you can close your app, and it's where you can open new tabs. So when you're in Chrome and you open tabs, each one of those tabs is a separate render process. One tab doesn't know about the other tab. And so this is how it works in Electron 2. Each render process is its own process. So I'm going to walk through a little super minimal example of how you can build an Electron app and how the pieces sort of work together. So the bare minimum that you have in an Electron app is a package.json that you have in a normal Node application. And that package.json is going to point Electron to where your main process file is defined. And in most cases, you can call it main.js. You can call it whatever you want, but main.js is a really good name for the main process. And then that main process file is going to point to an HTML file to open. So you've got a package.json, a main.js, and an index.html. Your package.json says something like this. It says main, and then the name of the file, that's your main process. Then in your main.js, you're going to use two modules that are for the main process. One is app. That's going to give you your app. And then the other is browser window. And so when the app is ready, you create a new browser window. You give it some dimensions, and then you tell it to load that index.html file. your index.html file, and this is where I wanted to show you, all right, this is an index.html file, but our browser window renderer process is loading it, which means we have full access to all of Node. So I hope that you can see this, but we have the normal HTML, and inside of a script tag, we have var fs and require fs, just like you're writing Node, but this is inside of HTML. Then we're using the JavaScript DOM and creating a new element, a new paragraph element, and then we can set that paragraph's content to, oops, I think I messed up some code there. But ignore the document part on the front of the fs. But fs.readFileSync, you can read a file and then set the content to that using Node directly with the DOM. So the next thing you do is you can install, there's a module called Electron Prebuilt that lets you execute Electron apps from the command line. So you install that, and then you type electron dot to execute that directory, and you get an Electron app. It says, hello universe, and you didn't know this, but the content of that file was the Octocat's name is Mona Lisa, which is also a true fact. And so we were able to read that file with Node and insert it into the DOM inside of an HTML file because of the way that Electron embeds it all into the same runtime. And just to prove that it's Chrome, you can also open up the DevTools in here, which is really useful for debugging and designing your app the same way you might with a website. So people are building things on Electron. There are companies building on Electron. There are companies like Slack and Microsoft who are building new products on Electron, and then there are startups that are building their product on Electron, and Jibo is one of them that you'll hear from soon. There are also a lot of fun open source projects being built on Electron, and I'm just going to give shout outs to two that I really like. I hope that Moji Bar changes your life. Moji Bar is written by another GitHubber, actually, Muan. And it lives just in your menu bar, and it uses a library of emoji keywords so that you can really find the one that matches the feeling in your heart instead of having to remember the emoji's name. And then another one is called Playback, and this is a video player that streams torrents, if you have any of those things. It also casts to your Chromecast. It has a playlist that you can share with anyone who's on the same Wi-Fi network, and it has a cool cat background. So there's fun stuff happening on Electron now, but we're working on Electron stuff for the future too. We are going towards a 1.0 for a stable, standardized API that we're hoping to hit in January, and to add in some more features like Mac App Store compatibility, and then more Windows support for like Windows 10 so that you can do all the things, provide APIs to the things that you would expect to be in these OSs. Then work on documentation, which is super important to me, and this is actually what I'm working on starting next week. But we've already got great documentation, but it can be better, and it can also be an Electron app itself. So we're going to build an Electron app that is all of the documentation with all of the APIs that you can interact with so that you're using Electron to test and see all of the APIs that you can use in Electron. We're going to continue to update Chrome and Node so that anything cool that Chrome ships you can use your fat arrows and Node if you want without Babel, because we're on 4 and we'll always be upgrading Node. And we're going to support the community, enable the tooling that they're already building. So earlier in my little demo thing, I mentioned Electron Prebuilt. We didn't build that. Someone in the community built that, and it's downloaded 40,000 times a month on NPM. It just lets you run Electron from the command line, and it's great. But we actually then added a webhook to Electron so that every time we cut a release of Electron, Electron Prebuilt can get updated with that latest release. And Electron Packager and Electron Compile are the same. They're really useful tools that are built by the community, and we want to support them however we can. So if you want to know more information about Electron, The website is electron.atom.io. Our repository is in the Atom org. We have a Twitter account, and we have a Slack, too. And you can get an invitation to the Slack there. And if you think this is super cool and that I might be fun to work with, you can come work with me. And we're hiring, so talk to me. Kevin is also here somewhere. Yes, in the back. He works on the Atom team, too. And we have the listing on GitHub's website. So that is Electron in a nutshell. And so next I want to give the stage to Jibo to talk about specifically how they're using Electron and the cool stuff that they're doing. So thank you.
Thank you, Jessica. So Jessica asked the same question, so I think I can ask the same question. How many people here know Jibo or have heard of Jibo? Come on. Cool. All right. Well, we'll have Jibo introduce himself in a little bit. But for those of you who don't know who Jibo is, we're a design-focused robotics company. We're bringing sociable robotics to the home. So without further ado, I'm going to have Jibo introduce himself.
Hi, my name is Jibo. I am the world's first family robot. I'm excited to show you some skills I've been working on. Check out my moves. I bring content to life, which makes me a great entertainer and storyteller. And I love to play with kids and help them learn. I want to help my family feel closer and more connected, even when they live apart. I can capture and share special moments like a cameraman. I can recognize you, listen to you, and interact with you like a hands-free helper. Finally, I am a platform. With the help of developers everywhere, my skills will keep expanding.
Thank you, Jibo. Cool. So Jibo mentioned that he's a platform. And we knew right from the beginning that we wanted to attract web developers, game developers, and mobile developers. So we knew we wanted to build Jibo using web technologies. And it's really funny because in Jessica's talk, she talks about the process they got to actually building Electron. And we actually went through a very similar process. We started looking at Chromium. Then we moved on to Chromium Embedded Framework, and it has its pros and cons. Then we looked at NWJS. And then finally, we arrived at Electron, and it kind of solved a lot of the problems that we were having with these other three frameworks. So we decided that we were going to run all of our skills, we call our skills apps, in Electron on Jibo. Bonus points, there's this IDE called Atom that's built on top of Electron. So we also decided to build our SDK as an Atom plugin. And this actually has some really beneficial effects. We can run the same code that's doing the motion control and all the other things on Jibo in our SDK as well. So it's actually very powerful. When you run in the simulator and the animation tool, all that's the same code as is running on the robot. So as a startup, that makes it really easy to work on multiple platforms. So our SDK is an Atom plugin. We have three main tools. An animation tool, a visual behavior tree tool. This is for encapsulating AI behaviors, and a robot info pane. Like I said, the skill runs in Electron in 3 different modes. It can run on the robot, and because we're built on web technologies, we can actually run the skill on your computer and have it connect to the robot through Wi-Fi, and I'll show that in a little bit. Or you can run it in the simulator, and the simulator is just a simulated environment. It runs all the same web services on your computer as are running on the robot. So like I said, all of our skills are basically an Electron app, but Electron has no robot parts to it. So we provide an NPM module called Jibo, and if you just include this in your skill, this gives you an API to all of the robot parts. So what are the robot parts? So just like a human, Jibo has various senses, listening and speaking. He has different types of audio speech recognition. He has embedded speech recognition, which can detect end of utterances, speaker ID. He also has cloud recognition for more unconstrained audio speech recognition. He has sound localization, so he knows where sound is coming from. So if you say, hey, Jibo, he'll turn around and he'll greet you. And sound segmentation, so if you're in a party and you're talking to Jibo, he can isolate your voice. He also has text-to-speech, so that you can have Jibo say whatever you want. It supports a subset of speech synthesis markup language. This is a markup language that allows you to enhance the text-to-speech attributes, so you can add emphasis, pitch shift, porosity to your text-to-speech, and plus anything you do in Electron. So the whole web, HTML5 audio, web audio stuff. In addition to audio speech recognition, which is just turning sound waves into strings, he also has to be able to understand what you're saying. And for this, we have a robust parser. Basically, you can think of it like regex for natural language understanding. And it supports things like date, time, US cities, things that you wouldn't want to write yourself. We provide all these factory methods for you. Seeing and perceiving, this is really important for a sociable robot. So you want him to be able to detect motion. So if you enter a room, he can acknowledge you. Face recognition, so he can see a face. Facial identification, so he understands the people who are in his family. Photo capture and sound events as well. Touch, he's a sociable creature and people like to touch. If you're petting your dog, you do like this. So he has sensors all over his head, so he can detect that, and also his screen is touch capable. The animation expression is one of my favorite systems. It is designed like a game animation system, so you have all the things that you would have in a game animation system, like blending, static and procedural animations. Except with the robot, you have these real degrees of freedom instead of in a virtual game. He has inverse kinematics, so as a developer, if I want him to look at a point in space, maybe a face or a person or motion or sound or whatever, you just give the animation system a point in 3D space, and it does all the math and inverse kinematics for Jibo to actually look at it. And there's different ways of doing this. He can do lazily, so he can move his eyes first and then his head, or he can do a more tracking mode where he's like, targeting in. And then other animation things that we built in, like blink. You can shape the eye, translate it, rotate it, texturize it, etc. I'll show that later. Cool. So enough about the features. I would like to show our SDK. Can you guys see that? Sort of? All right. They told me not to do 720p, so I'm going to trust them on this one. So what I'm going to do, I'm going to show you our animation editor. And I'll make that big. There we go. So you can see that. On the left-hand side is our body manipulation panel. I can just grab one of these sections and just move it left or right. So maybe we'll want to do like a greeting animation, actually. So we'll just start off here. We'll make this 60 keyframes. At keyframe 30, we'll have him lean to the side in acknowledgement of me, like that. And then at the very end, we'll just reset all and create a keyframe there. So it's a basic keyframe editor. It takes elements of Maya and takes elements of Flash and kind of puts it into one thing. Again, we're trying to go after web developers, and they know Flash and they know how to do keyframes. And game developers, they know Maya. So there we go. And we can actually preview this on the robot. So I mentioned that there's multiple ways of running Jibo. I'm going to run him remotely. So I'm going to run the skill of this little animation on my computer, and it's going to connect wirelessly to the motor feedback system on the robot. Right here, you just stick in the IP address. We call him MM. We name all our robots after Wu-Tang Clan members. And let me just make sure Gulp is running. OK. So this should play the animation that we just did. Yay. So you notice that we go back to the screen, you notice that the eye is actually playing on my computer, connected through WebSockets and using HTTP, all web technologies. To actually play him on the robot itself, we can just go to our build folder, and we just type in, let me make this bigger for you. Can you see that? All right. So I can just type Jibo run, press that. It takes a couple seconds. And there's our animation on the robot. So there's multiple ways you can run this, depending on your iteration cycle, how fast you want to iterate. Let's keep going with that. What time is it? OK, great. Let's do something with the eye. Maybe he wants to express an emotion like love. So let's turn his eye into a heart. The eye is a basic 3D scene, so we can actually change it using our, we call reshaping tool. And we can create a keyframe there. And maybe we also want it to be a beating heart as well. So we'll scale it down. Scale it down really small. And then at the very end, we'll scale it up really big, just like that. And let's see how that looks. Yay, he loves you. Hearts aren't white, so let's add an eye texture. And this allows us to color the eye, different colors, and add a texture to the eye. But we'll just do red for right now. And again, we can just run that right on the robot. I know the eye is hard to see on the screen there. So there's his eye. So again, this animation tool allows you to manipulate the eye, the body. We have an LED ring right here that is another expressive element. He has an eye overlay, so you can bring in a camera lens or like a camera shutter thing. He has an event system so that you can synchronize audio to events in the animation itself. And video references and all the things you'd expect with an animation editor. So that's great. We have a static animation, but maybe we want to make something a little bit more substantial. So what I'm going to do is I'm going to create a separate behavior, and we're going to call this idle. New behavior tree file. Call it idle. And what I'm going to do, so who here knows what a behavior tree is? Anyone in games at all? Some of you. OK. So a behavior tree lets you do things like sequences, run behaviors in parallel. That's basically it. It acknowledges parallelism, unlike a finite state machine. So in this case, we're going to run a parallel of two sequences. Add child, sequence. We're going to loop these sequences, so we're going to add a while condition. Cool. I'm going to copy paste. So now we have two sequences. So what I'm going to do is I'm going to create an animation. It's a procedural animation where he just chills. He's just going to sit there and look around, and maybe he's going to blink a little bit. So in each one of these sequences, I'm going to add a little timeout behavior. This just does nothing for a certain amount of time. So let's do between 2 seconds. I can make this bigger for you. 2 seconds and 4 seconds. Random. And then below that, we're going to add another behavior called blink. And we ship with all these basic behaviors: blink, play animation, look at, text-to-speech, listen, cloud listening, all sorts of cool things. And it's all included in our SDK. So let's just copy that timeout, because we like that. And below that, we're going to put a look at behavior. And again, the look at behavior just takes an object with an XY position, and then Jibo will do all the math to look at that place in space. Now I cheated and I pre-made some code here, so I'll just copy and paste that, just like that. And in our main BT, we're just going to reference that idle behavior. Oops. Cool. And we're going to stop the previous one. All right, so I hope this works. Moving, buddy. There he goes. Yay. He's moving. So again, you can just build out these huge behaviors, and we have all sorts of cool tools, and we're going to be shipping with things like greeting a person and like idle behaviors that are a little bit more complex that speak to human social code. So, and I just want to give a shout out to the Electron and Atom team. These products have been great, and we're building a whole company on them. So, thank you. I think, do we have time for questions? Yeah? Okay. Does anyone have any questions?
How much does it cost?
So we launched a campaign in 2014, June. We sold those for $600. Since then, they've gone up to $750. Sorry.
So my dad works this, so he's very excited.
Oh, cool.
So for like my dad who gets one of these, are there like tutorials or information for the non-programmers so they can interact programmatically with their Jibo? Or are you expecting them to more just like say hi and have it play music and things like that?
Yeah, so if you want to develop new skills on Jibos, right now we're concentrating on the more power developers, but we will be releasing sets of tools that allow you to, create really lightweight animations on him. And if he's really interested, downloading these tools, it's really easy. Atom Package Manager is super easy, and our animation tool is super easy. Yeah, so you don't have to know programming in order to use this. Hey buddy. We try to provide levels of power userness. So you can just use the visual tools, or you can jump right into JavaScript. So we try to provide a range. The SSML? Oh, that was a recording. Yeah, that was pre-recorded prompts. But the voice talent for that was the same voice talent that built our TTS corpus. So it should sound very similar. Oh, in the back. Yeah, so I mean, there's different forms of security on Jibo. I would say all web communication going back and forth is going to be SSL encrypted. There's going to be a token handshake between your app and the Jibo's services. And you have to put him into developer mode before you can actually run a skill remotely. So when he's not in developer mode, he's in kind of lockdown mode. He won't accept connections from outside. On top of that, there's other security that I want to talk about, probably really briefly. The skill itself, we're opening this to third-party developers, but the skill itself won't have access to the pixels of the camera. The whole local perceptual space is sending back structured data as JSON about where people are, where people are, where motion is, where sound's coming from, maybe the emotions on their face, but besides that, they don't get actual pixels. So we put and on top of that, we also sandbox the Electron process. So we chroot it, and we wrap it in seccomp. It's a Berkeley filter packet library that filters system calls to the OS. So when we launch a skill, it'll have a manifest file, just like in Android, that describes the permissions that it's allowed, and the platform will enforce that. Yep.
What's in there in terms of like RAM, CPU, stuff like that?
Yeah, I don't think we can talk about the specifics of the hardware just yet, just until we ship. So, but it's a very modern processor. It's going to be comparable to an iPhone or next generation iPhone. Yeah. Yeah. So that's a really good question. For as an owner. As an owner, it should feel seamless as possible. And from a design standpoint, that's actually a big challenge, because if you're bringing in all these third-party apps that have vastly different experiences, how do you create a unified experience across it. We're approaching this where there's kind of an Uber process. Think of your window manager on your computer. We call it Jibo B. It's his base personality, and he does all the skill switching for you. So there's a little bit of personality on top of that. But once you're in a skill, it's up, the skill has full control of the robot. Sorry? Yeah, the skill has a trigger, and it has a life cycle, just like any app on an iPhone. Yeah. Sorry, what was that last question?
One is probably a different question where, like, how many users have you got at the moment which would make you want to develop for this?
Right.
Have sufficient.
Yeah, so we have 0 users. Well, we have 10 users right now, which is our own internal skills team. Sorry, the question was, are we going to have an app store, and do we have users right now? We are going to have an app store, and we haven't launched a product, so we don't have any real users yet. Anybody else? All right, thank you very much.